Welcome, curious minds, to another deep dive. Today, we're peeling back the layers on something fascinating, a bit of tech that's quietly changing things.
That's right. We're talking about the global handheld 3D scanner market. Might sound a bit specific, maybe.
It might, but you'll see it's got this really significant growth story.
And we've got some fresh data here from cognitive market research to guide us. So think of this as your shortcut to getting up to speed on a field that's, well, moving fast.
Exactly. Our mission is to unpack some potentially surprising facts, look at the growth curve, and really understand why this tech is taking off.
Okay, so let's start with the big picture. Where does this market stand right now, or at least recently?
Right. So back in 2021, the market was valued at about $285 million. Just over $285 million, actually.
Okay, 285 million, and looking ahead.
That's where it gets interesting. It's projected to hit nearly $380 million, 379.4 to be precise, by 2025.
A decent jump in just a few years.
And then it really accelerates. The forecast goes up to over $671 million by 2033.
Wow, okay, so that's quite a trajectory. What's the growth rate look like?
It's a steady compound annual growth rate, the CAGR, of about 7.4%, just under 7.5%.
So steady, solid growth. But what exactly is driving this? I mean, what is a handheld 3D scanner doing that's making it so popular?
Good question. Fundamentally, it's a portable device, right? You hold it, you scan an object, maybe even a whole room, and it quickly creates a very precise 3D digital copy.
And that portability must be key.
Huge. That, plus they're becoming much easier to use. And, the technology keeps getting better, more accurate, faster.
So where are we seeing them used?
All over, really. Think precision manufacturing, quality control, reverse engineering parts. Healthcare is a big one, too.
For things like custom prosthetics, maybe? Or planning surgeries?
Exactly that. And even in, creative fields, design, animation, and preserving cultural artifacts digitally. It's kind of this bridge between the physical object and its digital twin.
A physical to digital bridge. I like that. And it feels like we're just scratching the surface of its potential applications.
I think so, too. Okay, so we have this global picture, this solid growth. Let's break it down by region now, see where the action is really happening.
Sounds good. Where should we start our world tour?
How about North America? Seems like a good place to begin.
Okay, North America. In 2021, the market there was around $80 million. A bit over, 80.4 million.
Right. And the projection for 2033?
It's expected to climb quite a bit, reaching over $176 million by 2033.
Doubling, more than doubling. And within North America, I assume the U.S. is the main player.
Oh, absolutely. The U.S. started at about $65.6 million in 2021 and is projected to hit over $142 million by 2033. So yeah, it's the dominant force there.
That's substantial. What about Canada and Mexico? Are they lagging far behind or showing growth, too?
They're definitely growing. Canada started around $8.6 million and is forecast to reach over $20 million. Mexico's looking to go from about $6.2 million to nearly $14 million by 2033.
So growth across the board in North America, what's fueling that, do you think? Is it just early adoption?
Well, early adoption is part of it, certainly. North America, especially the U.S., has these really strong industrial sectors, right? Aerospace, automotive, electronics. They jumped on this tech early for things like rapid prototyping and quality checks.
Makes sense. Faster design cycles, better products.
Exactly. And Canada and Mexico, while maybe starting smaller, they're tapping into it too. Manufacturing hubs there, plus growing interest in using it for, say, construction or documenting heritage sites.
Okay, interesting. So from North America's strong base, let's hop across the Atlantic to Europe. How does the picture look there?
Europe's got a compelling story too, though maybe slightly different dynamics.
Yeah.
The overall market was about $63 million back in 2021.
And the projection, similar growth.
Yeah, pretty similar in terms of doubling. It's expected to reach over $140 million by 2033.
And who's leading the charge in Europe? Is there a clear front runner like the U.S. in North America?
Germany definitely stands out. They started around $13.5 million and are projected to hit over $32 million by 2033.
Okay, Germany. That's not too surprising given their manufacturing prowess, their whole Industry 4.0 focus.
Precisely. Handheld scanners fit perfectly into that advanced manufacturing ecosystem for precision work, quality control, machine maintenance. It's becoming vital there.
But it's not just Germany, is it? What about other major European economies?
No, absolutely not. Europe's strength is really in its breadth. By 2033, you're looking at the UK contributing around $19 million, France over $16.5 million. Italy nearly $13 million.
Spain, too, I see here, around $14 million.
Yes, Spain, Sweden around $8.5 million. Even smaller markets like Switzerland, Denmark, Russia
Hmm.
are all showing steady, significant growth. It underlines this broad adoption across the continent.
For all sorts of different uses, I imagine. Industrial, creative.
Definitely. A very diverse application base in Europe.
Okay, now let's pivot to Asia Pacific. The numbers here look, well, pretty dramatic. Often the case with tech adoption.
Yeah, APAC is definitely flagged as a major growth engine. It boasts a really strong CAGR, over 8%.
8% CAGR. And the overall market value jump.
It's quite something. From just over $101 million in 2021, it's projected to surge past $256 million by 2033.
Wow, that's more than doubling, heading towards tripling almost. Who are the key players driving that? China, I assume.
China is certainly the biggest in terms of market size, yeah. Projected to hit around $79 million by 2033.
Okay. But you mentioned the CAGR was high for the whole region.
Yeah.
Is anyone else standing out?
India. India's growth rate is really eye-catching. It's got a projected CAGR of 9.2%.
Over 9%. That's impressive acceleration.
It really is. It means India's market is expected to reach over $30 million by 2033.
What do you think is behind that particularly rapid growth in India compared to, say, China or Japan?
That's a great question. It's likely a combination of factors. You've got India's booming tech startup scene, right?
Mhm.
Increasing investment in healthcare, which is a key application area, and also a big push on Make in India and local manufacturing.
So scanners become tools for innovation and local production.
Exactly. For everything from digitizing cultural artifacts quickly to helping small businesses with design and prototyping, it's quite dynamic.
And other major players in APAC.
Oh, yes. By 2033, you'll see Japan at over $35 million, South Korea getting close to $22.5 million, Australia around $13.3 million.
And Southeast Asia.
Southeast Asia as a whole region is also forecasted for strong growth, hitting over $26 million. It really shows this widespread digital transformation happening across APAC.
Okay, fascinating picture in Asia. Let's move down to South America. Still seeing healthy growth there.
Yes, definitely healthy. The CAGR for South America is projected at about 7.7%, so quite strong.
And the market size.
It's set to grow from roughly $19.7 million in 2021 to over $47.8 million by 2033. So again, more than doubling.
Who leads the way in South America? Is it Brazil?
It is, yes. Brazil is the clear leader, projected to reach over $18 million by 2033.
And why Brazil?
Yeah.
Similar industrial drivers.
Largely, yes. Brazil has a significant industrial base, plus ongoing infrastructure projects. So scanners are finding uses in construction monitoring, automotive design, maybe even archaeology and resource management.
Interesting. Any other notable countries in South America?
Argentina is expected to be near $9 million by 2033. Colombia, over $8 million. Chile and Peru are smaller, but still growing steadily. It's consistent adoption, often helping developing economies gain efficiency.
Right, bringing precision tech to new areas. Okay, how about the Middle East?
The Middle East shows steady growth, too, moving from around $11.7 million in 2021 towards over $28 million by 2033.
What kind of applications are big there? Is it oil and gas related or diversifying?
It seems more tied to diversification and major development projects. Think large-scale construction, urban planning, real estate.
Smart cities, perhaps?
Potentially,
Yeah.
yes. And also the growing entertainment and cultural sectors. Accurate 3D models are really useful there. Key countries by 2033 are projected to be Saudi Arabia over $7 million, Turkey near $6 million, and the UAE approaching $4.8 million.
Okay. And finally, let's touch on Africa. What are the projections there?
Africa's market, while starting from a smaller base, is also projected to more than double. From about $9.1 million in 2021 to nearly $22 million by 2033.
And the main player there, South Africa.
Yes, South Africa is dominant, expected to reach over $8 million by 2033. That reflects its more developed industrial base and tech investment compared to some other parts of the continent.
Any other countries showing significant movement?
Nigeria is emerging as a notable market, projected to hit over $3.8 million.
Okay. So even though it's smaller overall, the growth pattern is consistent globally.
Absolutely. It underscores this growing adoption trend. Even in regions perhaps facing different economic challenges, we're seeing demand in mining, engineering, education. It shows the broad utility of this tech.
So bringing this all together, after looking at all these numbers region by region, what's the main takeaway for you?
Well, it's clear this isn't just about niche technology anymore, is it? Handheld 3D scanning is becoming, I wouldn't say mainstream yet, but certainly much more integrated across a huge range of industries globally.
Yeah, it feels like a fundamental shift
Yeah.
from a specialist tool to something much more accessible and, frankly, essential for modern design, production, quality control, even problem solving.
Exactly. The portability, the ease of use we mentioned, the constant innovation, it's driving real-world impact everywhere, from small workshops to massive factories. It's a quiet revolution, maybe, but the numbers clearly show it's happening and accelerating.
It really paints a picture of technology becoming more democratized, more powerful in more hands.
Which leads to a really interesting thought, maybe for you listening. Given this rapid spread, this increasing power and accessibility,
Yeah.
how might handheld 3D scanning start to reshape industries or create possibilities in areas we haven't even fully grasped yet? What could this technology unlock in your own world, or maybe in your line of work? Something to ponder.
Welcome to the deep dive. Today, we're jumping into the really fascinating world of handheld 3D scanners. This isn't just about cool gadgets. It's technology that's fundamentally reshaping how we interact with the physical world.
Absolutely, across so many areas.
Yeah, from like high-tech manufacturing right through to preserving cultural heritage. And just so you know, all our insights today, they're grounded in some solid expert analysis from cognitive market research.
Good data is key.
Exactly. So we know we're working from a reliable base. Our mission for this deep dive is pretty clear.
Hmm.
We want to unpack the key forces, the drivers pushing this market forward,
Right.
and also look at the challenges, the restraints it faces, and maybe peek at the exciting trends shaping its future.
Sounds good.
Okay, so let's unpack this. What's really propelling this market forward right now? What are the big drivers?
Well, I think one of the biggest areas is definitely industrial inspection and quality control. For manufacturers, where even tiny defects can be super costly, these scanners are, well, they're revolutionary. They let them quickly and accurately spot deviations.
Oh, by capturing the geometry.
Exactly, capturing these really intricate geometries in like real time. The big benefit there is preventing delays down the line, cutting down on rework, minimizing waste. It's huge.
Makes sense. Less waste, better products.
Right. And it's not just about speed, it's also democratizing that precision. You're bringing lab-grade QC right onto the factory floor, makes zero defect much more achievable.
Wow.
And then there's reverse engineering. That's another heavy use case.
Ah, right. Taking something physical and making it digital.
Precisely. Engineers can convert existing physical parts into digital CAD models, that's computer-aided design,
Got it.
which lets them recreate, analyze, or even redesign older legacy parts with amazing accuracy.
That's incredible. You can really see the practical benefits in industry.
Yeah.
Changing how things get made, how they get checked. But let's widen the lens a bit. It's not just about factories and engineering labs, is it? Where else is this tech making a difference? Maybe in ways we don't immediately think about.
Oh, absolutely. If you look beyond the industrial side, there's this rapidly growing adoption in healthcare, medical applications.
Okay, like what specifically?
Well, think about dentists, for example, using them for really accurate orthodontic planning, getting braces or aligners to fit perfectly.
Ah, makes sense.
Huh.
Better fit, better results.
Yeah. And prosthetics experts, they're using them to custom fit artificial limbs with just remarkable accuracy. That really transforms people's lives.
Wow.
And even in surgical planning, they're creating these super detailed 3D models of a patient's anatomy.
Before the surgery.
Before the surgery, yeah.
Yeah.
Which means better precision, potentially better outcomes, directly improves patient safety and recovery time.
That's amazing. But the impact doesn't stop there, right? You mentioned culture earlier.
Exactly. Art, design, cultural preservation. It's a real game changer there, too.
Yeah.
Artists, museum folks, they're digitizing sculptures, monuments, priceless artifacts.
So creating like a digital twin.
Sort of, yeah. It gives them a kind of digital immortality, preserves our heritage against, well, time and decay, but also makes it accessible to anyone, anywhere in the world, digitally.
Democratizing access, like you said, with QC.
Mm-hmm. And one more, maybe closer to home for some listeners, gaming and film.
Ah, okay. How are they used there?
Well, scanners are kind of the unsung heroes. They convert real-world objects, props, environments, even actors sometimes, into digital assets.
Which save time, I imagine.
Drastically speeds up design workflows, yeah.
Yeah.
While keeping that visual fidelity, that realism, it really bridges the physical and digital worlds quite seamlessly.
It's just fascinating how this one technology branches out From like ensuring a perfect engine part to preserving ancient history to creating fantasy worlds.
It really is versatile.
You really start to see how it touches so many different aspects of our lives. But, okay, with all that transformative power, it's easy to gloss over the hurdles. Every big technological leap has its challenges, right?
Always.
So, what are some of the main roadblocks? What's holding things back? Or maybe making adoption trickier?
Well, probably the biggest one, and it's a significant hurdle, is the cost. The high initial investment.
Right. These aren't cheap gadgets.
Definitely not. Advanced high-res scanners, they can cost anywhere from, say, $5,000 up to $50,000, even more sometimes.
Wow, okay. That's serious money.
It is, and that price point often puts them out of reach for, small businesses, individual artists or creators, maybe even some schools or universities.
And it's not just the sticker price, is it?
No, exactly. There are ongoing costs, too. Maintenance, software licenses, those updates, hardware calibration to keep them accurate, replacing accessories. It all adds up.
That's a pretty substantial barrier, especially for smaller players.
Yeah.
Does that mean the market is mostly, like, big companies right now?
It definitely skews towards larger enterprises, yeah. But there are efforts to make it more accessible. Still, another major challenge kind of ties into that: the complexity.
Complexity in actually using them.
Using them and processing the data. Operating a professional-grade scanner isn't always, intuitive. Point and shoot, it is not. It takes some knowledge, understanding scanning angles, how to align the object correctly, and then the really crucial part, data optimization.
What's that involve? Cleaning up the scan?
Yeah, basically. Refining that raw scan data, removing noise, fixing errors, making it actually usable. And after you capture the data, you often need pretty powerful software.
Right.
And the skills to use that software effectively, to turn those, clouds of points into a clean, usable 3D model. It takes expertise.
So a steep learning curve, potentially.
It can be, yes. And then there are also environmental and surface limitations to consider.
Okay. Like what kind of things interfere?
Well, these scanners mostly work using structured light or lasers. They project patterns or beams onto the object to measure its shape.
Right. I've seen those light patterns.
Yeah. So surfaces that are very reflective or very dark or transparent, they can mess up the scan.
Why is that?
Because they scatter the light unpredictably or absorb it instead of reflecting it back cleanly to the sensor. So you often need to treat the surface first.
Like with a spray or something.
Exactly, like a matte spray to get a good scan. And using them outdoors can be tricky too.
Ambient light, sunshine.
Yep. Sunlight or even bright ambient light can just overwhelm the scanner's own light source, making it hard to get accurate data. So these factors really limit where and how effectively you can use them without taking extra steps.
Those limitations are really important to grasp because, like you said, they often drive the next wave of innovation, don't they?
Absolutely. That's where engineers focus.
It shows where the breakthroughs need to happen, making them tougher, easier to use anywhere. And that leads us perfectly into our final bit. What's trending? Where's the industry heading? This is where it gets really interesting, I think. Shows us how they're tackling those challenges.
Definitely. And one of the really big trends right now is the integration of AI, artificial intelligence for data enhancement.
Okay. How is AI helping?
Well, it's starting to automate a lot of the really tedious stuff, things that used to take hours of manual work.
Like that data cleanup you mentioned.
Exactly. Scan alignment, reducing noise in the data, even hole filling, where the AI intelligently figures out and reconstructs missing bits of the scan.
Wow.
It saves a huge amount of time, obviously, but it also boosts the accuracy, even if you're scanning really complex or, irregular shapes.
So smarter scanners?
Smarter scanners. Some are even using AI to give the user real-time feedback while they're scanning, like guiding them on the best path to capture the data optimally.
That's cool. Like having an expert looking over your shoulder.
Kind of, yeah. And building on that smarter processing, another huge trend is cloud-based data processing.
So moving the heavy lifting off the local computer.
Precisely. Instead of needing a super powerful, probably expensive local PC to crunch through those massive scan files, users can just upload the raw scans directly to a secure cloud platform.
And it gets processed there.
Processed and stored there, yeah. This is like revolutionary for teams working remotely or big design firms, even schools. It allows seamless collaboration no matter where people are.
And frees people from needing the most powerful hardware locally.
Right. It really democratizes the processing power you need for these complex scans, makes it much more accessible.
Makes sense. Collaboration and power.
And then finally, we're seeing a really significant push towards miniaturization and mobile integration.
Smaller scanners.
Lighter.
Much smaller, much
Right.
lighter. And some are even becoming smartphone compatible.
Wait, so you could scan with your phone? Essentially, yeah. Turning your mobile device into a pretty capable 3D scanning tool. Imagine you're walking through an antique market, you see some amazing carving.
You could just scan it.
Potentially, yeah. Scan it right there with your phone,
Hmm.
turn it into a 3D model you can use for inspiration, or maybe even reproduce later.
That really lowers the barrier to entry.
Massively. It opens up scanning right there in the field construction site, historical dig, outdoor photo shoot, whatever. It makes 3D scanning suddenly accessible to freelancers, small shops, educators, people who probably thought it was completely out of reach before because of cost or complexity.
So, tying this all together,
Mm-hmm.
what does this mean for you listening right now? It really sounds like we're heading towards a future where this tech, super powerful tech, just gets easier to use, more accurate, and way more accessible.
Mm-hmm.
It feels like it could genuinely impact, I don't know, everything from how we shop online, how kids learn at school, how we engage with art.
I think that's right. To kind of put the big picture into focus, the handheld 3D scanner market, it's moving incredibly fast.
Yeah.
Driven largely by these innovations we talked about, AI, the cloud, mobile access. Now, the challenges, they're still there. Cost, complexity, those environmental limits, they haven't vanished.
Right. Ongoing work.
Ongoing work. But the demand is clearly growing across so many different sectors, manufacturing, healthcare, culture, entertainment. That demand is steadily pushing adoption upwards.
It really is. And
It
it leaves
is.
us with a pretty compelling thought, doesn't it? Just
Yeah.
imagine as this ability to instantly digitize, our physical world gets better and easier. How might that change everything? How we save history,
Yeah.
how we create totally new realities.
Yeah.
So here's something to ponder. What physical object in your life right now would you want to preserve or maybe recreate first if you had this technology in your hand?